guys, let me just recap what we did. Just 2 minutes. Okay. Sorry about that, guys. There was a problem with the microphone. This is all the learning objectives we're going to be covering today. And I was just saying, what's a magnet? A magnet is anything, any object that has got a magnetic field around it, like this one over here. Now, a magnet will also have 2 poles. Can you guess which poles will they have? Quite easy. North and south. Okay, so at these poles over here is where the magnetic field is strongest. So that's why when you're trying to pick up things with a magnet, I don't know if you've ever tried it before, over here the magnetic field is much stronger. Okay, so don't worry about magnetic fields and about how to draw them, because we're going to be covering them in much more detail in the second part of the lesson. Okay, so what's a pole? It's a magnet's end, and it can be north or south, like I drew before. A magnet is an object that has got a magnetic field and is also affected by a magnetic field. But there are certain magnetic objects that are not magnets. We'll talk about that later. Okay, so what did you notice about these lines? What do you think they mean? What happens when you put a south pole next to a north pole? Do they come close together? So do they attract? Or do they move away from each other or repel? Remember, guys, attract is when they come close to each other. Repel is when they move away from each other. Okay, guys, you can use a Q&A in Microsoft Teams chat. So on Microsoft Teams, where you're watching the presentation, you will have a chat. Then you can ask questions there. Either the moderators or me will answer everything for you. Okay, so tell me, guys, try to participate. What do you think will happen when the South Pole comes near a North Pole from a different magnet? Will they attract? Will they repel? Come on, guys, share your answers. Don't be shy. Okay, while you're doing that, let's move on. When 2 magnets are brought together, the magnetic fields interact and they exert a force on each other. Exert is like apply, okay? So don't worry if you're finding these words a little bit difficult. I know that you're still in year 6, so some of the vocabulary will be a little bit difficult for you, but don't worry, guys. Okay, so exert is the same as apply. When 2 magnets are close to each other, that means that the magnetic fields that they have, they are also interacting with each other. So remember, magnetic fields can be a little bit like that. So when they interact, what's happening? Well, when 2 like poles meet, like means either north and north or south and south, they repel. Remember that repel is move away. Okay, perfect. So you put north against another north, they will push the other magnet away. Okay, so now there's a different story for unlike poles. So unlike poles are different poles, okay? So different. And it could be north and south, or south and north, they will attract each other. So they move closer, okay? They experience a force and it brings them closer. Okay, so you might have heard the sentence before, opposites attract. Well, in the case of magnets, that's completely true, guys. Okay, so try to match the magnetic poles to their attraction. That will be the first one, guys. So we've got south and north. They are attracting each other. So south is trying to move towards the north, and north is trying to move towards the south. Okay. And then these ones are slightly different. We've got south over here and south over here. Remember, like poles repel. Once again, repel is moving away or pushing away. Okay. Let's see if anyone has participated yet. They're a little bit shy today, guys. Okay, let's move on. Non-contact forces. Okay, so what do we mean with non-contact forces? If you bring the two magnets close to each other, we've got one magnet here with north and south, another magnet here with north and south. They're attracting each other, but do they need to be in contact? No, right? So if you separate them, there's nothing in between, just air. There's nothing for them to be in contact, but they still experience a force. That's what we mean with non-contact forces. For example, for you to push a box, unless you've got superpowers, you would need to physically touch the box to be able to apply that force, no? But for a magnet, that doesn't need to happen. They can be far away from each other and still experience the force. Okay. So, as I said, without physically touching, they can create forces, okay? So, can you think of at least one more example of a non-contact force? Think about it, guys. Let's see if you can give me some answers in Microsoft Teams chat. Well, guys, I want you to participate. Write down in Microsoft Teams chat one more example of a non-contact force. Okay, I'm gonna give you a few examples and then you can choose. Pushing a box. Gravity. Okay, which of these three do you think, let's call this 1, 2, and 3. Which of these three you think it will be a non-contact force? Write your answers in Microsoft Teams chat. Okay, guys, I'm gonna give you 1 minute. Okay, let's check your answers. Hey guys, it seems you've been a little bit shy today. So the answer, guys, was gravity. Well done for trying. So another one would be nuclear forces. Okay, nuclear forces do not need to be in contact to exert a force. Okay, so the mystery of electromagnetism. Electromagnetism, which is electricity and magnetism together. If you didn't notice, electro from electricity and then magnetism from magnetism. Gravity and the nuclear forces are the four fundamental forces that exist all across the universe. So don't worry, this doesn't apply to you, but all these forces, scientists suspect that they were all grouped together in a very, very, very small spot just before the Big Bang. Okay, so it could be that in the future, electricity and magnetism will split into two separate forces, but we'll probably won't be living when that happens. Okay. Let's try to test your knowledge, guys. Join at slido.com using the QR code or using the code below 1413837 and answer the question, what do magnets stick to? Copper, wood, iron, or plastic? I'm gonna give you 1 minute for this, guys. Hey guys, come on, you need to join at slido.com. Just type on your browser or on your phone, slido.com. And then use that code, 413837. Okay, guys, 30 more seconds. Okay, so it seems no one has tried to participate, guys. You've been a little bit shy today. So the answer is iron. Okay, copper is not a magnetic material. There are only a few magnetic materials in the periodic table. That's iron, it's cobalt, and it's nickel. Now, some people say, oh, steel is also magnetic. Well, steel contains iron inside, so that's why it's magnetic. Okay, so we got another question. I'm going to give you another minute, guys. You need to try and join and participate in slido.com. When two magnets repel, they change color, pull together, push apart, or get colder. I'm going to give you 1 minute for this. Okay, guys, 30 more seconds. Okay, 10 seconds. Okay, guys, come on, you need to try and participate. Join at slido.com using the code. It's really easy. Okay, 5, 4, 3, 2, and 1. The answer is push apart. Guys, remember, when two magnets have got the same pole, they repel, and that means that they push apart. They move away from each other. Okay, we got another question, guys. I'm going to give you another 30 seconds, and then we're going to move on. Okay, 10 seconds left. 5, 4, 3, 2, and 1. So, the force of magnetism is stronger when magnets are closer together. It's obvious, guys. If you separate the magnets too much, they will not experience the same force, and at some point they will not experience any force, or the force will not be big enough to be able to move the weight or the mass of the magnet. Okay, so you don't necessarily need to know about this, but think of it. Okay, think of the word electromagnet. Electro and magnet. What would increase the strength of an electromagnet? Think of it. How can you increase the strength of an electromagnet? That was a little clue there. I'm gonna give you 20 seconds for this one. Oops, I already showed the answer. Sorry, guys. Well, I gave you the clues that you probably figured out. Is increasing the amount of current flowing through the wire. Okay, so we've covered all of these 4 subtopics and learning objectives. What's a magnet? how magnetic poles work, non-contact forces, and the mystery of electromagnetism. Now, what are magnetic materials? You got a photograph there. What do you think will happen if I bring a magnet close to these paper clips? What do you think will happen to the paper clips, guys? Write your answers in Microsoft Teams chat. Come on, guys, try to use the Microsoft Teams function, okay? There is one chat where you can type in Microsoft Teams. Even if it's just to say hello, please say hello. Try to participate. Come on, guys. Okay, so let's continue with this. Once again, a magnetic material is a material that is affected by a magnetic field, like iron. Now, you remember the other I mentioned? Cobalt, nickel, and which one was the other one, guys? This is not an element, but it contains one of these metals, and that's steel. Okay, steel is also magnetic because it contains iron. Good. Okay, so a magnetic material will be any material that can be attracted to a magnet. Okay, and also, guys, it can be converted into a magnet. I will show that to you later if you're able to participate in Microsoft Teams chat and show your presence. Okay, so as I said, we got iron, steel, cobalt, and nickel. Now, do magnetic materials repel? Well, quick answer is no. Okay, magnets can repel each other if you put like poles together. So remember, south and south and north and north. Okay, but a magnetic material will be attracted both to the North Pole or the South Pole. It doesn't matter. Okay, so any magnetic material, so paper clips, can be attracted both to the North or to the South Pole. Okay, so let's move on, guys. As I said, any magnetic material, so iron, steel. Sorry, guys, let me close the window 1 second, because the neighbor's making a little bit of noise. Okay, guys, sorry about that. Had to close the window. My neighbor decided to start some woodworking today. Okay, so as you can see, we swapped the magnet, so it doesn't matter if it's north or south, the magnetic material will be attracted to both. Okay, so what do you think I'm showing you in this picture? This is some kind of American donut. What is it, guys? Let's see if you can write your answers in Microsoft Teams chat. Well, guys, this is red blood cells, okay? And now red blood cells contain something really important, which is iron. Inside here, okay, that's on this dip that you will learn that in year 10 or year 11, that increases the surface of the red blood cell so it can carry lots of oxygen. So it's just like a pocket, and the pocket is full of iron, guys. Iron joins with oxygen and then is carried around your body to provide oxygen for all your cells. Okay. So if you hold a magnet near some blood, nothing in it moves. And that's because the iron is too far apart and diluted to be affected by magnets. Okay, so you cannot, don't worry, if you use a magnet around your body, you will not be attracting these iron particles as they are really tiny. And they're also tightly attached to the red blood cells. Okay, guys, so one thing that you can actually do, and I promise this works, if you get one of these cereals like, what's this called? The Kellogg's one, the most typical cornflakes, okay? You smash them until you get a fine powder. Then if you use a strong magnet and you move it around a few times, well, like a good 100 times or so, from outside of the bag, you can actually get little pieces of iron. You will see like little black powder accumulating, and that's iron that is included in the cereal. So when they say that cereal contains iron, they really mean it, guys. Okay, so quick question again, guys. Are all metals magnetic? Write it down. I answer in Slido, guys. Join Slido. It is really easy. Call your parents if you don't know how to do this. Use their phone or use the internet browser. You can use the phone, scanning the QR code, or go online on slido.com and use the code 413837. I'm going to give you 30 seconds. Okay, 5, 4, 3, 2, and 1. Guys, only a few are magnetic, like iron, steel, cobalt, or nickel. Not all metals are magnetic, okay? Okay, so really easy fill in the gap question. Magnetism is a type of force, book, field, or animal. I don't know any animal that is called like that, but if you know, who knows? Okay, guys, 20 seconds for this answer, and then we're gonna move on. Okay, 10 seconds. Five, 4, 3, 2, and 1. Guys, it's a type of force. Okay, so we've covered another 3 subtopics, 3 learning objectives, and those are: what are magnetic materials, do magnetic materials repel, and magnetic materials in blood. Okay, so there are 2 main type of magnets. We've got the permanent magnets, who are magnetic all the time. Okay, so magnetic all the time. And then we've got induced magnets, which are only temporarily magnetic, so not all the time. Now, I don't know if you notice, if you've got a magnet around at home, you can try. So let's say that you've got a magnet north and south, and then you grab a paper clip. If you notice, that paper clip becomes an induced magnet. That's because it's in the presence of a magnetic field of another magnet inside a magnetic field of another magnet. Now, do you think you could do this with a piece of wood, with a pencil, for example? No, you would not be able. The material, for it to become an induced magnet, needs to be magnetic. So if you notice, if you have a magnet and you pick up one paper clip with a magnet, and then with that paper clip just connected to the magnet, you try to pick up another paper clip, you will be able to do so. And the paper clip was not magnetic before. So why did that happen? Well, that's because this magnetic material, the paper clip, would be able to attract other paper clips as it becomes an induced magnet. Okay, let's move on. So, permanent magnet is always magnetic. Okay, so most important thing, always magnetic. Some examples: toy magnets, compasses, and fridge magnets. Okay, so most popular shapes are the horseshoe magnet, which is this one. If you notice, it's similar to a horseshoe. And then the next one would be the bar magnet, which is this simple one. Okay, it looks like a little bar. Okay, this is not correct, guys. This is not magnetic material. This is magnetic field is what I wanted to write here. So magnetic field is a space around the magnet where a force acts on other magnets or magnetic materials. So it's magnetic field. Okay. Now, we're showing you this, but you probably don't even know what this is. This is where us older people used to listen to music with, I don't know, 20 years ago, when there was no CDs, okay, and also to watch films. Okay, so they use kind of a kind of permanent magnet, and then the video and sound is encoded in the magnetic coating of that reel. Then you can just put it into a radio cassette or a VHS video player, and you'll be able to see your films or listen to music. Something a little bit old school for you guys. Okay, so hard drives. This is a little bit more modern. Hard drives use permanent magnets to store information. So that circle, everything here that you see here, that's magnetic material. So the needle, this needle will be reading the magnetic material, and it will do a combination of 1 and 0s, which is a binary code. You don't need to know this, okay? But this is what computers use to read and store information. Okay, computers work in binary code with 1s and 0s, and with that they can create and display massive amount of information. Okay, so we're going to be talking about a different type of induced magnet, but first let me check Microsoft Teams in case there are any questions so far. Seems that there isn't. Okay, so an induced magnet is a material that becomes a magnet when it is placed in a magnetic field. This one in the picture is not exactly an induced magnet. Okay, this one is an electromagnet because it can be turned on and off by using electricity. Okay, so permanent magnets are, as I said, always magnetic. But induced magnets can become magnetized when they are near a permanent magnet. If you take them away, they will not be magnetic anymore. Sorry, they will not be magnets anymore. Okay, let's move on, guys. Do induced magnets repel? Let's see. At the moment, they're both attracting. So this one, okay, could be, for example, the paperclip that I showed you before. Induced magnets will always experience a force of attraction, not repulsion. Well, if it was an electromagnet, that wouldn't be the case, okay? But we're going to be talking about that later. So induced magnets will always experience a force of attraction. So imagine paper clips or a needle that you just have magnetized, okay? So after the first break, or maybe after lunch, I don't know, I'll show you how to create your own compass in case you're lost one day in the middle of nowhere and you got a magnet on you, you could create a compass to find the north. Now, electromagnets, guys. So electromagnet is a type of an induced magnet that works when you coil a wire like that. Coil means make little circles with it, okay? And because electricity carries a magnetic field, when you coil it like that, you create a similar magnetic field to the one of a bar magnet, okay? And as I said before, near the edges, it becomes stronger, okay? But actually, in an electromagnet, the strongest field is, even if you cannot see, is inside the electromagnet. So if you remove the core, you remove that little piece inside the electromagnet is where the field will be strongest. Okay, so how is, once again, this magnetic field created? So this magnetic field is created thanks to electric current. It's an electromagnet, so it needs electricity. So you don't even need a metal core here. Just with electricity, if you coil a wire like that, you will be able to create a magnet, okay? So, like other induced magnets, the effect is temporary. There is not magnetic forever. So once the current is switched off, once there is no current flowing through the wire, then the electromagnet has no magnetic force. Think of some uses for this and share it in Microsoft Teams chat. Why would it be useful to turn on and off an electromagnet? Okay, in 10 minutes, we're gonna have 9 minutes, we're gonna have a little break. Okay, guys, so some uses that you could have for this electromagnet. If you see this picture, that might give you a clue. So in a scrapyard where you need to move large pieces of metal, it is very useful that you can turn it on and off. Because if it was a permanent magnet, once you pick all that scrap up, what would happen to it? It will be stick there forever. Okay, it will be hard to remove. So then all you need to do is stop giving it current, and then it stops being magnetic and you can drop all the scrap whenever it needs to be dropped. Okay, so in New Mexico, they created such a strong electromagnet that if you turn it on for 15 milliseconds, if you turn it on for more than that, it will destroy itself. So strong that it will just collapse and destroy itself, okay? So what do scientists do with this? Well, they study particles, atoms, and all these things around them, around this magnetic field, and see how they behave, okay? But this time, even if it looks like very little time, because they got really, really powerful machines, they're able to gather lots of data from it. Okay, so once again, let's do a little recap. You need to match the qualities to the magnets. I'm going to give you 30 seconds to think about it. You can do it in your books. You can take a screenshot and then paste it on Word and make your own lines. I'm going to be solving it in a second for you. Okay, guys, you got 30 seconds for this. Okay, guys, 10 more seconds. Five, 4, 3, 2, and 1. Okay, guys, so permanent magnets can experience attraction and repulsion. They generate their own magnetic field, and one example is kitchen magnets. Induced magnets include electromagnets. They're temporary, and they only experience attraction, guys. Okay, so what are we looking at over here? What is this, guys? Roller coaster. You're correct. So mix of both. Sometimes you can use induced magnets and permanent magnets for one purpose. So in roller coasters, induced electromagnets can be used to facilitate magnetic propulsion. So thanks to that, the cart is able to move. As you know, the cart doesn't have a motor, it's just being pushed thanks to electromagnetism. Okay, so permanent magnets are used as brakes. So the coaster doesn't fall in a power outage. So imagine that you were at the top of this loop and then suddenly the electricity would stop. Well, you wouldn't just fall and hurt yourself because the magnets will act as brakes and keep you there. Okay, guys, I'm going to give you 30 seconds for this slider question. 10 seconds. Seconds. 3, 2, and 1. Okay. Guys, this question is actually meant to be for year 11s. Okay, we haven't even talked about domains. Domains is something, and I will draw it to you, is something that is inside magnets. When all the domains are pointing in the same direction, that's when the magnetic force can happen. If domains are pointing in opposite directions, then the domains cancel each other and there is no magnetic force. Okay, so we're going to skip this question and we're going to have a look at this one. So Rachel has a small block of metal. She wants to know if it's a magnet. The only thing that she's got is another bar magnet. So when she holds the north pole of the bar magnet near one end of the block of metal, they attract. Then she flips it and now she's holding the south pole. Okay, so north pole attract, then the south pole also attracts. So explain how that shows that Rachel's block is not a permanent magnet. Remember, permanent magnets can both attract and repel. So if this is true, then this must be an induced magnet. Induced magnets only attract, okay? Sorry, induced magnets or magnetic materials, okay? Only attract. And this is exactly what's happening with this material. This metal is a magnetic material, but it's not a permanent magnet. Remember, being magnetic and being a magnet is not the same. Magnetic is that you can be attracted towards magnet, and then a magnet is the one that actually makes that force, okay? So it did not repel either end, therefore should be a magnetic material. So iron, steel, or an alloy of iron, but also, guys, if you remember, I mentioned cobalt and nickel. Okay, guys, I'm gonna. It's 10:56, so I will see you back at 11:01. You've got a 5-minute break in case you're gonna get some water or go to the toilet. So I'll see you back at 11:01. Thank you very much.